Okay, sir. Good morning, everyone. I'm Ashweni Chettri from 5th semester, and the topic for my today's presentation is dark matter. My contents are introduction, dark matter, what is dark matter versus dark energy, what kind of objects made up this dark matter, brief idea on dark matter, and finally the conclusion. What is universe made of? In the standard model of cosmology, the total mass energy of the universe contains only 5% of ordinary matter, and the remaining 95 is made up of dark matter and dark energy. As for today's presentation, we'll only be discussing about dark matter. I'm going to start with an introduction. In 1933, says astrophysicist Fitz Zwicky, who studied galaxy cluster while working at the California Institute of Technology, made a inference. Zwicky and evidence in the world trunculated as with all those conclusions, Zwicky inferred some unseen matter provided the mass and associated gravitational attraction to hold the cluster together. Vera Rubin, Ken Ford, and Ken Freeman's work in 1960s and 1970s provided further strong evidence, also using galaxy rotation curve. An influential paper presented Rubin and Ford result in 1980. They showed most galaxies must contain about 6 times as much as visible matter. Thus, by around 1980, the apparent need for dark matter was widely recognized as a major unsolved problem in astronomy. Dark matter is widely recognized as a major unsolved problem in astronomy. So, what is dark matter? Dark matter is some form of material that neither emits, reflects, nor absorbs electromagnetic radiation such as radio waves, light, gamma rays, etc. Therefore, invisible. Difficult as normal matter will be about me like an holds the universe together. Dark energy, meanwhile, it works as a repulsive force, a sort of anti-gravity that drives the universe ever accelerating expansion. Dark energy is far more dominant force of the two, accounting for roughly 68% of the universe's total mass energy. Dark makes up 7%. What objects of this dark matter? Some of the dark in our galaxy may exist in what are known as massive compact halos or meteors. Meteors are believed to be made up of ordinary baryonic matters. They include objects such as planets, moon, brown dwarfs, dust clouds, white dwarfs, neutron stars, and black holes. Over the past few years, astronomers have detected several types of meteorous objects in our galaxy. While meteors could be account for some of the dark matter, scientists believe that there is much more out there. And some of the matter may exist in what is known as non-baryonic matters. This type of matter would be composed mainly of exotic particles. These exotic particles have equal exotic names such as neutrinos, exons, supersymmetric dark matter, and WIMPs, weakly interactive massive particles, although WIMP have been predicted in theory, and none have as of yet been detected. If these theories prove to be true, WIMPs could account for a significant portion of dark matter in the universe. So now we are going to talk about a brief idea on dark matter. Dark matter binds galaxies together. Dark matter exerts gravitational force, meaning that it draws other matter towards it. And there's so much dark matter that its gravitational force is enough to hold enough entire galaxies together. That's why dark matter is often likened to a giant spider web messing galaxies in place. It distorts the appearance of space. When astronomers observe distant galaxies, they often appear stretched, oddly shaped. This effect is known as gravitational lensing, and it is caused by dark matter's gravitational force. So this force is huge that it physically bends light around galaxies, distorting their appearance. Misbehaving galaxies. The first hint that we might be missing something came in 1930s when astronomers noticed that the visible matter in some cluster of galaxies wasn't enough to hold the cluster together. The galaxies were moving so fast that they should have gone jingling out of the cluster before long, leaving no cluster behind. It turned out there is a similar problem with individual galaxies in 1960s and 70s. Astronomers mapped out how fast the stars in a galaxy were moving relative to its center. The outer part of every single spiral galaxy the scientists looked at were traveling so fast that they should have been flying apart. Something was missing, a lot of it. In order to explain how galaxies moved in cluster and star in individual galaxies, they needed more matter than scientists could see. Astronomers call this missing mass a dark matter. So we have finally reached the conclusion, and there's still a whole lot we don't know when it comes to dark matter, and some mysteries might never be unraveled. But as technology advances, we are edging closer towards the truth. Thank you.
Okay, thank you, Ashwini. That's quite a nice presentation. Do the students have any questions? Oh, before the questions, let me just remind you all, you are all supposed to register for the webinar on Monday. The link is in the unofficial group. Make sure you have all registered for it. Okay. Right. Now, do you have any questions for Ashwini? Seriously, nobody has questions on dark matter? Like one of the biggest open problems in physics right now? Okay. So, ma'am, do you have any questions for Ashwini?
Okay, so Ashwini, in your introduction slide, you have mentioned about virial theorem. Okay, so do you know virial theorem? Like my question is from uh, in the heat in thermodynamics chapter. There also, I think you have learned about virial theorem. Uh, Means this virial theorem in your dark matter and the thermodynamics virial theorem, are they same? Ashwini, you are muted.
Yes, ma'am. No, ma'am.
So, can you tell me the virial theorem? Like, no was what? No was your answer.
Ashwini, you're muted. Do you know what the virial theorem is?
No, ma'am.
Okay. Um, I have another question. So you have mentioned that this dark matter, they are non-baryonic matter. So my question is, what is baryon? Do you know?
Ma'am, ma'am, very unique.
Yes, yes. What is baryon?
It is only composed of baryons and
See, I am asking from nuclear physics, from that point of view. Okay. So tell me, what is baryon? You have studied no nuclear physics, nuclear and particle physics.
You would have done this in modern physics, no? Back in semester 4. Classification of particles.
Baryon, lepton, uh, some examples. Do you know, Ashwini?
ma'am, this baryonic matter it includes like proton, neutron, and all the other composed of them.
Okay, see, my question is not baryonic matter. I am asking just only about the baryon. Okay, uh, that's all from my side.
Digvijay, sir?
Uh, so, Ashwini, you talked about dark matter, and in one of your slides, you mentioned dark matter is attractive, and whereas dark energy is repulsive. Could you explain like how it was? Uh, how was it discovered that the dark energy is repulsive? Ashwini?
Ashweni, are you there? How do you know that dark
Yes,
energy
sir.
is repulsive?
So here that I have only
Yeah,
one
to be fair,
in dark
she did
matter.
only focus on dark matter. She's just
But
presenting dark
yeah,
energy as a
yeah.
contrast.
I just wanted to know because in one of your slides you had mentioned why and how it was repulsive, right? Acceleration of the galaxies.
Yes, sir. Like I give like only the brief introduction and like not also introduction and the brief idea on dark energy, sir.
Yeah. Okay, sir. That's all from my side.
Okay. Thank you, sir. Right. So let's talk about your presentation. It's short. It could have been longer. Dark matter is like a huge topic, so I think it could have been longer. Few things. First of all, your voice is kind of low. And if your voice is a little bit low, people are going to think that you're nervous. Now, maybe you are actually nervous, or maybe you weren't nervous, but the lower your voice is, and what I mean by lower voice means if you mumble really softly like this, sometimes people won't be able to figure out the exact words you're saying. So you kind of need to put a little bit more force on your voice, even if you're feeling nervous. Uh, Okay.
Okay,
Yeah,
sir.
because that will help with your presentation. Because if your voice is too low, then all the effort you made into they'll start losing attention, and then all the effort will that you made into at least presenting it will sort of kind of go to waste. Aside from that, presentation was nice. I like the slides. Some of your slides had a lot of text on them. You kind of want to reduce them, or you want to use animations to bring them one at a time. I kind of talked about all of this, but aside from that, presentation was fine. No major issues. Anything that's a baryon is something that has three quarks. For those of you who don't know, a baryon is a kind of substance, is any sort of particle that has three quarks. So we have protons, neutrons, and their anti-particles. Those come under baryons. In terms of ordinary matter, they are the most common type of, not common, they are the most, in terms of mass, they are the most extensive type of ordinary matter outside of dark matter. And like, I don't really have too many questions for you because I don't know. I think your prep could have been better, but so I'm not going to really ask too many questions. Just out of interest for people who, if they have any interest in them, dark matter was first hypothesized back in the 1880s. Like I know you talked about Zwicky. Zwicky's paper is the starting paper for anyone who wants to study dark matter. And I have a personal love for that paper because that is the first research paper I ever studied. When you want to read on dark matter, that is the starting paper most people look at. That's Zwicky's 1933 paper. But back in the 1880s, Kelvin was already speculating that there was a matter that was not accounted for because they did a visual calculation of all these stars in the Milky Way, and they found out that the mass does not add up to the rotation of the Milky Way. So at that time, they didn't think of dark matter or anything. They just assumed that there were dark stars and planets and dust and gas that they could not see visually, which was basically accounting for a large amount of unexplained mass. Back then, it was just called missing matter. Then in the 20s, people like Urt and there were a few Danish astronomers. They were the ones who were starting to kind of speculate that there was mass that was not accounted for in a lot of galaxies. And that's how the whole dark matter phenomenon started going on until Zwicky wrote his very, very famous paper. Right? And then from there, it worked on. The topic on Vera Rubin, and I think her PhD, what was the name of her PhD advisor? Ashweni, it was there in his slide. Rubin, and who's the other guy?
Sir Ken Ford and
Yeah,
Ken
Ford.
Freeman.
Yeah, so Ford was her PhD advisor. They did the work on the rotation of galaxies, which is very, very important in establishing that something like dark matter should exist. Ford got a Nobel Prize. Rubin, who did most of the work, did not. It's considered to be a major, not scandal, but a really, really bad look for physics at the time because Rubin, the reason they didn't give it to her was Ford got a lot of credit because he was the professor, obviously. Rubin at that time was just a graduate student, and also there's a lot of talk that it was because she was a woman, which is why they kind of snubbed her in the Nobel Prize. So there's been a lot of discussion about how Rubin was snubbed, and this has happened. Unfortunately, like this kind of snubbing has also happened a lot of times in other points in physics. If you want to look, Lisa Meitner is another example of that, and another astronomer as well. I forget her name, but she's the one who basically gave conclusive proof that the sun contains hydrogen. So unfortunately, it has happened, and it's well worth like looking into the history of this, just so that we know that this has happened in the past. Yeah, but aside from that, decent, good presentation, Ashwini. There are some parts that you should definitely be able to improve, like your delivery, your speech delivery, and your time. And obviously, you need to prepare some more on the question and answer session. In an actual conference situation, like if you ever have to present yourself, they will ask you some fairly tough questions. All right, so you need to be prepared for that. But aside from that, it's pretty good. Okay.
Yes, sir. Thank you, sir.
All right. Does anybody else have any follow-up questions, anything like that? Oh yeah, by the way, virial theorem. Virial theorem is the average kinetic energy of a substance will usually be 2 times its potential energy. This is not always true, but it comes from classical mechanics. You will be learning it in stat mech next semester, if you have not already. It is there in astrophysics. Not always true, but it is also used heavily in astrophysics. Okay. Yeah, that's. Does anybody else have any follow-up questions?